In this video, we are going to find the acceleration unit vectors in spherical coordinates. These are velocity vectors for the spherical coordinates we derived in the last video. So we are going to differentiate this with respect to t. We are going to do product rule for this term and triple product rule for this term. I will do it in easier way. R head double dot equal d by dt for theta dot theta head plus d by dt for phi dot sine theta phi head. I'll find this and then I'll find this and substitute them. D by dt theta dot theta head. I'm going to simplify this considering this function f and this is function g. So I'm going to differentiate phi dot and multiply it with g sine theta phi head plus f as it is phi dot times the time derivative for sine theta phi head. I'll write this in different color. Let's compute the red expression. Theta dot theta head is equal to theta double dot theta head plus theta dot theta head dot theta head dot is just that thing here. So this will be minus theta dot square r head theta dot plus theta dot phi dot cosine theta phi head. So this is the red expression. For the green, d by dt sine theta phi head theta dot cosine theta phi head plus sine theta phi head dot theta dot cosine theta phi head plus phi head dot is this thing here, and we are multiplying it by sine theta. Then we have minus phi dot sine square theta r head minus phi dot sine theta cosine theta theta head. Back to our expression. I will write the red component as it is. And then add phi double dot sine theta phi head plus this thing multiplied by phi dot then I will write it like this: minus phi dot square sine square theta r head for the r component minus phi dot square sine theta cosine theta theta head plus theta dot phi dot cosine theta phi head. So this thing will be added to the red component. The final form will be minus theta dot square plus phi dot square sine square theta r head plus theta double dot minus phi dot square sine theta cosine theta, theta hat plus phi double dot sine theta plus 2 theta dot phi dot cosine theta phi hat. Now for theta hat double dot, we are differentiating theta hat dot, which is equal to minus theta dot r hat plus phi dot cosine theta phi hat. Theta hat double dot equal d by dt minus theta dot r hat plus d by dt phi dot cosine theta phi hat. I can do the same trick for this part, differentiating phi dot times cosine theta phi hat plus phi dot times the time derivative of cosine theta phi hat. Computing d by dt for minus theta dot r hat equal minus theta double dot r hat minus theta dot r hat dot. R hat dot is just theta dot theta hat plus phi dot sine theta phi hat. Theta hat minus theta dot phi dot sine theta phi hat. For this part, I'll take the derivative of cosine theta phi hat. This equal to minus theta dot sine theta phi hat plus cosine theta phi hat dot. Phi hat dot is minus phi dot sine theta r hat cosine theta theta hat. Phi dot sine theta cosine theta r hat minus phi dot sine square theta theta hat. Theta hat double dot equal to minus theta double dot r hat minus theta dot square theta hat minus theta dot phi dot sine theta phi hat. And then phi double dot cosine theta phi hat and the derivative times phi dot. So I take this multiplied by phi dot for R component minus theta double dot minus phi dot square sine theta cosine theta, taking the minus as a common factor, theta double dot plus phi dot square sine theta cosine theta r hat. For theta component, we have minus theta dot square and minus phi dot square sine square theta, taking minus as a common factor, theta dot square plus phi dot square sine square theta, theta hat. And for phi component we have these three terms: phi double dot cosine theta minus 2 theta dot phi dot sine theta phi hat. And this is our theta hat double dot phi hat dot, which is equal to minus phi dot sine theta r hat minus theta dot cosine theta theta hat. I won't do triple product for these two terms. Instead, I'll take minus phi dot as a common factor. Then phi hat double dot equal to minus phi double dot times the same bracket minus phi dot theta dot cosine theta r hat plus sine theta r hat dot minus theta dot sine theta theta hat plus cosine theta theta hat dot phi double dot sine theta minus theta dot phi dot cosine theta r hat, and then minus phi double dot cosine theta plus theta dot phi dot sine theta theta hat. And we will left with minus phi dot sine theta r hat minus phi dot cosine theta theta hat. This dot dot. I'll compute minus phi dot sine theta r hat dot minus phi dot sine theta r hat dot is theta dot theta hat plus phi dot sine theta phi hat. This equal to minus phi dot theta dot sine theta theta hat minus phi dot square sine square theta phi hat. And then I'll compute minus phi dot cosine theta theta hat dot minus phi dot cosine theta minus theta dot r hat plus phi dot cosine theta phi hat equal theta dot phi dot cosine theta r hat minus phi dot square cosine square theta phi hat. I can notice that this component is here also, but in different sign. I can cancel them. Also, for r hat, we have theta dot phi dot cosine theta here, and minus theta dot phi dot cosine theta here. I can cancel them. These two, I can take minus phi dot square as a common factor, and I will left with sine square theta plus cosine square theta, which is equal to 1. And this is our phi hat double dot.